Okay, the question is calculate V1 and V2 in the circuit of the figure using nodal analysis. Okay, we are given the node that we are looking for is this node here, V1, and this node here, V2. So we are looking for the voltage in node V1 and also the voltage in node V2. But let's first take a look at the circuit and let's infer what information that we can have from here. Okay, we have this one is the ground, so the voltage here will be 0. So let's label that. So the voltage here will be 0. And we have this current source, so the current will going up because the arrows is going up here. So it's going up and eventually goes into V2 here. So this is 15 ampere. This current is 15 ampere, right? Because the magnitude of this current source is 15 ampere. Okay, good. And then now let's assume that this current is going like this. And this one, remember that these three components is in series. So all of them will have the same current. So this current will continue to this one and then this one. But the problem here is that we have this voltage source, right? But let's remember that the property of the voltage source. If we have this one here like this, and this one is 10 volt, okay, and we know this node here and this node here, the difference between this node and that node will be the magnitude of this voltage source. So I will have VA minus VB here. VA minus VB in this case is equal to 10, right? And this is also the case for this, right? Because this is V2. Maybe let's name this V3. So in our case here, we will have V3 minus V2 will equal to 10, right? Because the positive one is V3. So I will have this case is V3 and then minus V2, right? And we will have 10 volt there. Or we can rewrite this like this. V3 is equal to V2 plus 10. And this will be very helpful later. Okay, now let's do KCL at node V1 and also at node V2. Let's start from V1 first. Let's start from the node V1. Let's do KCL at node V1. Okay, and KCL said that the sum of the current that goes in equal to the sum of the current that goes out. The only current that goes in is this one, but we can also rewrite this current here as V3, where the current comes from, and then it goes to V1, where the current goes to, divided by the resistance between them, so I will have 2 ohm here. Okay, and then the current that goes out, which is this one, and we will have V1. Okay, and then it goes to the ground, which the voltage is 0. So V1 minus 0, and then divided by the resistance between them, so I will have 8 here. Okay, I want to get rid of the denominator here, so let's multiply both sides by 8. And so we will have 4V3, because 2 and 8 will cancel into 4. So I'll have 4V3 minus 4V1. And V1 minus 0 is just V1, but 8 and 8 will cancel each other, so I will have V1 here. Good. And now we have V3 here. Let's plug that in. So I will have 4. V3 is V2 plus 10. So I have V2 plus 10. And then minus, okay, let's move that to the right hand side, right? So let's equal this. So I'll have V1, then plus 4V1. Okay, we can distribute this 4. So I will have 4V2 plus 40. And that will equal to 5V1. Okay, let's rearrange this. So I will have 5v1 minus 4v2, and that will equal to 40. I think we can save this as equation number 1. Okay, good. Now we have two variables, so we need one more equation. Let's do another KCL, but this time at V2. Let's do exactly that, KCL at V2, which it says that the sum of the current that goes in will equal to the current that goes out. The only current that goes in is this one here, which is 15 ampere. So I will have 15 on the left hand side. And then the current that goes out, this one here, right? So I will have this one, which is V2 minus 0. V2 minus 0 divided by, I think we will have 4, right? 4 here. And then plus the current that goes out. And remember, all these three current is the same, right? This one, and this one is all the same. So we can also choose one of them because they are in series. So I will choose this one here because that is easy to calculate, right? Because that one will be V1. So I have V1 minus 0 and divided by 8. Okay, now let's multiply both sides by 8 again to get rid of all the denominator. 15 times 8, that will be 120. And then 4 and 8 will cancel out into 2, so I will have 2v2. And then 8 and 8 will cancel each other, so I will have v1 here. Okay, let's rearrange this. So I will have v1 and then plus 2v2, and that will equal to 120. Let's save this as equation number 2. So now we have two equations with two variables. We should be able to solve it, and the fastest way to solve it is by using calculator. Okay, let's do that. So let's set up our calculator, and equation solver is number 5, two variables is number 1, and we can just plug in the coefficient. So I'll have 5 and then minus 4, and then we will have 40. Good. And then we will have 1 and then 2 and then 120. Okay, so I will have V1, which is 40. Nice number there. So I will have V1 is equal to 40 volt. And then what is V2? V2 is the Y value there, right? So I will have V2 also 40 volt. And that is exactly what we need from this problem. Okay, I think that's all. Thank you for watching. See you in the next video. Bye-bye.